Here's lesson 69, number 13, and it has a picture of a function, and it wants you to write the equation of problem 13 as a cosine function and 14 as a sine function. So when I want to draw something as a cosine function, I have to remember what the parent function graph looks like. So cosine, the parent function, always, if this is the y-axis and this is the midline, if it's the parent function, this is actually the x-axis. Cosine starts high and it goes low, high. I don't know if that makes any sense. High, low, high. In other words, the graph doesn't pass through the origin or through the midline. This is cosine. Sin x is different. Sin x would go like this, right? Sin x, this is y equals sin x. Okay, I'm asked to use cosine. So what I want to do is get a high point or a maximum of the graph. I'm thinking about things like the midline, the amplitude, the period, and the phase shift. So I want to let's start first things first. I always use this little mnemonic device, MAPS, or you can say CAPS if you want to, center line. I use midline. You're going to go to the midline, and then you're going to add the amplitude times cosine, and then times the period, which we'll talk about that, and then this is going to be a phase shift. Phase shift is a horizontal shift. Midline is actually a vertical shift. So the first thing we want to do is find midline. So you go to your picture. There's my picture. The midline is this dotted line here. I see the y-axis here, and the y-axis is numbered with a 9 and a 1. So I know that midline is halfway between 9 and 1. So what I like to do is I ask myself, how far is it between 9 and 1? You know, not thinking about negative numbers or positive numbers. I just want the absolute value of how far. If I had to walk from 1 all the way up to 9, I think it would be 8. Or in other words, 1 plus 8 would make 9. So I know that the whole distance between the 1 and the 9 is 8. I know this midline is halfway there. So I know, I shouldn't write in my book with, here, let's get me a pencil. Here's a pencil. I know that from there to there is 4, because it's half of 8. So if I want to know that midline, I can go 9 minus 4. Well, 9 minus 4 is 5. So I think that this midline is 5. You know, and I can check it. Is 5 minus 4, that makes 1. So I think my midline is 5. So I'm going to stick the 5 in here. Let me use my pen. And that part's done. Now I need a number that's going to multiply cosine. So the number that's going to multiply cosine is the amplitude number. And the amplitude is the distance from the midline to the high point. Okay, so the distance. So I already did that work. I know that from the middle to the top is 4. It goes up by 4 and down by 4. So that's going to be a 4. And then you might be asking, what about the plus or minus? Am I going to flip this thing upside down? So that is a little bit confusing. See, if I chose to scoot the graph to the left by pi over 8, then I would have a reflection of cosine. But they want you to move it to the right. They want you to take this high point and scoot it to the y-axis so that it will go downhill from the y-axis. Because see how the parent function, it goes downhill from the y-axis. It is true that you could scoot it left and then you'd have one that went like this. If this is y and this is x, this graph that I'm showing you right now this is y equals negative cosine x. It's the exact same graph as y equals cosine x, but it got flipped over the x-axis. It got reflected over the x-axis. So, like if it were on a test, and you decided to write this, if you decided the phase shift was pi over 8 rather than 3 pi over 8, and you just thought of it as being shifted over there, I wouldn't mark it wrong. But I think somewhere in the book, when they first, if you use this little lesson correlation sheet, and you go back to where they first taught you about this stuff, the author of the book, I think they said, when in doubt, we want to not reflect it over the x-axis. So I'm going to choose to view this graph as something that when it was the parent function, this point was right here. So it got scooted left by 3 pi over 8. It got scooted to the left, so it's going to actually be x plus 3 pi over 8. Because I'm imagining that it did. I have a pencil, so I can write it in there. This point, you know what I mean? I'm trying to explain to you that I'm trying to like take this whole graph and scoot it over a little bit. Okay, because that would make it look closer to what the parent function is, right? Because the parent function goes through the y-axis at a high point and downhill from there. So I'm imagining that at some point it was here like this, just like the parent function, but somebody did a phase shift on it. They moved it to the left, so I'm going to go plus, because remember how horizontal shifts, they're always x minus h, so they're always like opposite. This, hopefully you understood where we got this from. That's the amplitude. I decided not to flip it upside down, otherwise that would be a negative number, or that would be a minus sign. So that's all good. The only thing we need now is the period. So the period comes from how stretched out or compressed the graph is. The parent function graph has a period of 2 pi. So I want to see what this one's period is. So I'm going to probably just find the distance between negative 3 pi over 8 and 5 pi over 8, because from there to there, that's a complete cycle of cosine. See, like from the top to the top, that's a complete cycle. So I have to do some fraction math. I want to figure out, I'm basically going to add 3 pi over 8, because that's how far it is from this high point to the middle, to the y-axis. I'm going to add that to 5 pi over 8. So that would be 8 pi over 8. 3 pi over 8 and 5 pi over 8. That's 8 pi over 8. That's how far it is from this point to this point. So that tells me that this function makes one cycle for every pi or whatever. So that means it would make 2 cycles for 2 pi. So that makes this number be a 2. Now that was kind of easy because it was pi, and it was half of the regular period. If it weren't a real easy number, if that didn't turn out to be pi, but it was something weird like 13 pi over 8 or something, you'd probably want to take 360 or 2 pi for this number, and then you divide it by whatever's shown on your graph. Like in this case, we had 3 pi over 8 plus 5, that was 8 pi over 8, so we had pi. You take 2 pi and then you divide it by whatever the graph shown is, and then divide, and then that's where the 2 comes from. And I'm going to check that and make sure that that's correct. Number 13. Yep. And that's how you do it.